All right. Thank you so much for having me. I really appreciate it. Uh, of course, it's an honor and a pleasure to be here. So by way of introduction, my name is Yuri Grinshteyn. I'm a site reliability engineer at Google. I'm part of the customer reliability engineering team. So unlike other SREs at Google who work on Google systems and own the reliability of those systems, CRE or customer reliability engineering works with Google Cloud customers to help them do things like conduct reliability reviews, build shared monitoring, conduct joint reviews for incidents, and generally coach and guide customers that we work with to adopt and implement SRE practices and principles. So that's my background. And as I've already been introduced, today we're going to talk about some fundamentals of site reliability engineering, especially as you get started. What are some things that will likely lead to success in adopting SRE within your organization, and what things may cause you some problems. So let's get into it. I want to start by talking about the operational cost of software, right? We know that software engineering is typically focused on designing and building systems, much less so on operating systems. But we know that running an operating software post-launch is actually much more expensive, perhaps even 10 times as expensive as it is to build it. Organizations often focus on hiring good software engineers, but they don't invest nearly as much in their operations, staff, organizations, practices, or tooling, because generally, it's often seen as like someone else's problem. And that in itself is a problem. So why is that? Why is that the case? Well, let's consider the traditional software development model, right? Developers build new features and then they kind of throw things over the proverbial wall to the operations team, and then they move on to the next thing, the next feature, the next release, or maybe even the next project. Operators, on the other hand, have to juggle everything that's being thrown at them, while being responsible for the scalability, reliability, and maintenance of the software. And so we have this tension where incentives for developers and operators are fundamentally not aligned. Developers want to go as fast as they can to achieve maximum velocity. Operators want to slow down to reduce risk to the system in production, right? This is not designed for harmony. It's very brittle and it really doesn't scale well. And I'm sure a lot of you have heard of DevOps, right? So DevOps was kind of this attempt to remove these organizational silos, right? So how does SRE relate to DevOps? Ultimately, these are related, but different approaches for addressing that fundamental friction in software development, right? SRE is an opinionated implementation of DevOps based on practices that we have found to work here at Google, right? So this is kind of how we describe, we say that class SRE is an implementation of DevOps. So what are we trying to solve for here? Let's consider the product lifecycle, right? We start with a concept, the business vets it, right? The product goes to developer and launch, and then on to operations, right? And there's a couple of points of friction here. The first point is this friction or this kind of tension between the business and development, right? And agile development is supposed to address that. And then the tension between development and operations, which is what I've just described, is supposed to be addressed by DevOps. Okay. So if that's already the case, what is SRE? What is site reliability engineering? How does it fit into this cycle? As a lot of you probably know, this is something that was originally developed in Google, at Google back in the early 2000s, about 2003 or so. And there's really a framework to operate and scale systems reliably without being overwhelmed as the systems grow, right? The VP at Google, who kind of is given a lot of the credit for inventing SRE, Ben Traynor-Schloss, his line is, SRE is what happens when you ask a software engineer to design an operations function, right? The emphasis really should be on the engineering part of site reliability engineering and building solutions to allow us to run systems in production at scale, right? This really is a very versatile model to support mission critical systems, no matter how large or small the organization is, right? So the objective of this talk, the objective of this presentation is really not to convince you that SRE is the way to go or that it's the right thing for your organization. Instead, what I'm going to be talking about from here is how you might get started once you make the decision that this is actually appropriate for you, your service, or your organization, and how the SRE model is going to be different from other models that you may be using today. At its very core, SRE can really be distilled into these four main principles, right? The first one is we need service level objectives with consequences. Now, I'll talk in detail about each of these. SREs, or site reliability engineers, have time to make tomorrow better than today through software and systems engineering driven improvements. Site reliability engineering teams have the ability to regulate their workload through automation or pushing back on developers when the operational load is too high. And finally, failure is an opportunity to improve, right? We remove the word blame for our vocabulary. We know that things will go wrong. We treat failure as normal. We want to remove the incentives for people to cover up incidents and faults, right? We want to find those things that if we can address them, we will make the system more robust and more reliable, right? And ultimately, you can't run an effective organization from the basis of fear, right? Whether it's the fear of being blamed, fear of losing your job, fear of not getting the right performance review or a bonus or whatever the case may be. Okay, so how does SRE fit into the product lifecycle? Well, the objective is to really bridge business development and operations all together by giving everyone a common language and shared language around service reliability. So how do we do that, right? These principles are all well and good, but the reality is that actually doing this, actually getting started with this is quite daunting. So for the rest of the talk, I'm going to go through 4 of these key principles and give you some ideas about how you might actually introduce them to an organization. So our first principle, service level objectives, right? We're going to introduce them, we're going to define them, and I'm going to show you how to use them to understand how reliable your systems are. Okay. So what is an SLO? What is a service level objective? It's basically just a goal for the reliability of your service. Does your service meet the needs of its users? It should be tracking your customer experience, which means that if you are meeting your SLO, your service level objective, your customers or your users are happy. If you're not meeting your SLO, your customers are sad, angry, frustrated, and you may be in danger of losing. So here's some examples of how you might actually put SLOs into practice, right? As simplest, obviously, would just be an uptime, right? Something like, we have 99.9% uptime. Sometimes you'll hear that be referred as 3 nines of uptime. But this isn't really nuanced enough. What we need is a very precise definition. So here's some examples, right? Your HTTP server responds with success, often enough, fast enough. Your log processor processes enough log entries fast enough if data staleness is a problem for you, right? Good SLOs means that you have to pick goals for measures that track your customer's actual experience. And ideally, you want to set goals on things that your customers really care about. Now, you can imagine that SLOs can get very complex, right? When you start to involve user expectations. One of the things that my team has actually produced is a workshop called The Art of SLOs. And if you just do a Google search for it, you'll find those materials that will help you actually go through these materials in details. One question you may be asking yourself is, wait, what about SLAs? Well, we really should disambiguate the two, right? An SLA, a service level agreement, is typically a legal agreement or a contractual agreement between 2 different organizations that will carry penalties for not meeting the reliability targets that are promises. SLOs, or service level objectives, are defined around thresholds of customer happiness, right? Meeting your SLA does not necessarily mean your customers are happy, right? Not meeting your SLA means you're probably going to have to give your customers your money back, okay? I define an SLO, or at least a good SLO, is if I'm not meeting my SLO, my customers are starting to get unhappy, right? This should be well before we're in danger of violating the actual SLA where they're going to be getting their money back. So typically an SLO would be something that's used as an internal measure of reliability within your organization. And an SLA is something that is used kind of between companies or between parties that have financial transactions. So what's next? SLOs are, their foundation, right? But without consequences, they lack any actual useful impact, right? If you miss your SLO, if there's no consequences, like, what does that mean? Well, you need consequences. So you need a policy that describes what will happen if you don't meet your SLO, right? This is called an error budget policy. So how reliable do you want to be? Well, if you ask the sort of maybe organization's leadership or the powers that be, what do you think they'll say? More, 100%, as reliably as possible. Start with 100% reliability, demand perfection, and you need to treat any failure, no matter how small, as an emergency. But we know that the only truly reliable systems are the ones that do nothing at all and never change, right? Or anything change around it. They essentially exist in a vacuum, hermetically sealed off from the world, and that's impossible, right? And to drive this home further, consider Murphy's Law. Anything that can go wrong will go wrong, right? This is, those of us that have worked in operations, we know this is true. Let's add Finagle's law of dynamic negatives. Anything that can go wrong will go wrong at the worst possible moment. So if that's the case, why do we think that 100% reliability is achievable or even desirable? Well, a key realization that, again, going back to Ben Trainer's loss, had was 100% is the wrong reliability target for everything, right? Will your users even notice if you're not 100% reliable? And do you have to hit 100% to achieve customer happiness? No, absolutely not, right? So SRE is about achieving balance between competing concerns, right? We want to focus on establishing what is an acceptable level of failure, right? We know we know that it's not zero, right? Some failure is going to be acceptable because we know that 100% reliability is not the right target. So that delta between 100 and whatever we think the right value is, that's where we need to be, right? And we need to balance that against other aspects of your business. So this lets us move fast when things are good. And then when failure happens, we respond appropriately. And so that delta between 100% and our actual target is called the error budget, right? This is the budget that we have for failures. Error budget is basically the difference between 100% reliability and our SLO, our service level objective, our reliability target. Okay. While we're within budget, we're more reliable than the goal. And when we run out of budget, we need to invoke the consequences we've agreed upon. So a simple example, if you have an uptime SLO of 99.9%, that means you can actually be down for 0.1% for the month, right? That's 43 minutes. So if you have a 20-minute outage, you actually still have another 23 minutes of downtime budget to spend that month, right? Error budget is meant to be spent to go faster with innovation, feature development, experimentation, testing, whatever the case may be. Now, it doesn't mean you don't respond to incidents if you have error budget available. You don't want to waste the budget on incidents. So you should always be reacting with the appropriate level of urgency. But what happens if you do have problems and you actually spend the entire error budget? Well, that means you are unable to meet your reliability objectives, unless it's the very specific case where you've spent all of your error budget exactly at the end of the evaluation period. But if that is not the case, if you're out of error budget before your evaluation period is up, that means you did not meet your objectives and something needs to change. And your error budget policy is going to describe those consequences, right? This is not going to be financial consequences, right? But it's going to be something that will materially and visibly improve the reliability of your service. And there are many different possible error budget policies, and you have to obviously pick the one that suits your service, your business, your users, whatever the case may be. But here's just some examples, right? So you could freeze launches. You can only focus on postmortem retrospective action items from during your sprint planning. You need to have a recurring meeting with the software development team. This last one is actually something that we recommend folks do weekly or bi-weekly already. But maybe if you are out of error budget, that meeting has to happen daily and, until error budget is being recovered, right? So this is all part of our first principle. You need service level objectives to set reliability targets for your service, and you need consequences as defined in an error budget policy to tell you exactly what is going to happen if you're unable to meet those objectives. So what are some takeaways, right? We haven't actually talked about how an actual SRE fits into this, right? The principles can be applied in any team, any organization, any company, no matter your structure, if the application in question has good SLOs and an appropriate error budget policy, right? You also don't need to implement everything I'm going to talk about today at once, right? We're talking about getting started with site reliability engineering. So this first principle is actually how you might inspire interest in SRE in your organization to begin with. Now let's proceed on to the next one, which is making tomorrow better than today. And this is where I'm going to be talking about what the first SREs in the company will actually do. How can you succeed in enabling your first site reliability engineers to follow our model and not just run your existing system and your existing team under a new name, right? We know that SLOs and error budgets are the first step, right? The next step is defining what someone who has the SRE role or the SRE title will actually do. They need to have real responsibility. They need to be engaged in operating the system and empowered to do things when something goes wrong, right? So what is the first SRE going to work on? Well, they need to define and refine the SLOs, right? Because they're going to be the best placed person to see that the error budget policy is enacted when necessary. Ultimately, they are responsible to the user directly, and they need to make sure that the application meets the reliability expectations of those users, right? This person's charter is to think of reliability as the most important feature of the product, right? Because if the product is down, if the product is unreliable, doesn't matter how good the other features are. So when we talk about making tomorrow better than today, what does that actually mean? Well, we have to talk about toil. Toil is any work that is manual, repetitive, automatable, reactive, lacks enduring value, and grows at least as fast as its source, right? This is a major part of operating systems in production, and it must be part of the role, right? You have to do the work to keep the production systems running, but this must be a bounded part of the role. We recommend actually putting a cap on how much time folks spend on toil. At Google, it's 50% for SREs, right? Because if the SRE doesn't have time to do other things, if all of their time is spent on toil, they're just doing ops work, right? So if they're only doing ops work 50% of the time, what do they do with the other 50% of the time? Well, they do engineering work, right? SREs are engineers. They might be software engineers, they might be systems engineers, they might be a mix of the two. But engineering project work is the most important piece of the job for SREs. Here's some examples of the kinds of projects that might actually be doing. But remember, there's a focus here on making things better over time. They should be working on things that can have a benefit to the SLO or fixing things that might impact the SLO. They might be automating things that cause toil, right? But one of the big outcomes we're looking for here is that if we actually give SRE teams time for this kind of work, we find that it both makes them happier in the short term, which obviously is great. We want happy people to work for us, but it also empowers them to actually dig themselves out of holes, right? It gives them that power to fix problems that they identify and not just say, hey, there is a problem. It actually empowers them to fix it. Over time, the real benefit is it actually makes your systems more robust. It minimizes future toil. It reduces operational load. Ultimately, we as SREs, we live in fear of operational overload, right? Because we know that work will compound until we're just fighting fires and doing nothing other than ops, if we in fact do not spend half our time preventing that via project work. So let's summarize our second principle. Site reliability engineers have time to make tomorrow better than today. And we do it by capping our effort around operations and toil and giving ourselves and be given space to do project work. So what are some kind of a few takeaways here, right? The job of an SRE is not just to suffer under operational load. You actually want to make each day better, right? Better can mean lots of different things, but ultimately you're looking to reduce toil, reduce operational load, and improve the resilience, stability, and reliability of the system. All right, spend less time on toil, more time on meaningful system improvements. So the third one we're going to talk about is regulating workload, right? Again, we're talking about getting started with site reliability engineering, which takes us into our third principle, which is that SREs have the ability to regulate our workload. And one typical way of doing this is by actually having SRE be a different part of their organization, which is a team who's responsible for running mission critical software in production and keeping it reliable, right? Now, this might not be the right model for your organization, so just use this as an example rather than a prescriptive or the only possible functioning model. So you can absolutely create a site reliability engineering team by taking an existing team and changing the name on the door, right? That certainly can be the case. But just dumping production services, all production services on an SRE team is not going to work, right? Getting started will work a lot better if you start with SLOs, if you build up some principled approaches to engineering to those SLOs, and then you actually prioritize your most mission critical systems to be owned by SRE in production, right? It doesn't actually make sense for SRE to own everything. For example, here at Google, SREs are a relatively scarce resource, certainly compared to software engineers. We are here as a force multiplier, right? We want to enable scale. We want to enable systems to take on a lot more users without having to linearly grow the operational work that it takes to keep them up and running. But we're not a gatekeeper, right? We shouldn't have the only keys to production, right? If an SRE team takes on everything in production, right, from the most critical to the tiniest of services, you're not actually setting them up for success, right? Because you are creating overload, right? And overload is a real problem, and it creates a vicious cycle because an overloaded team doesn't have time to make tomorrow better than today, right? So you have to deal with the most important pieces first. If an SRE team is successful to begin with, they will take on responsibility for more and more production services, production systems over time, but it cannot all happen at once, okay? So you need to implement a mechanism to give some back pressure to the SRE team's development partners to provide balance, right? You need to share the responsibility for running the application in production, with some products being partially or entirely owned by dev or DevOps, right? Or, prior to SRE taking them on, you can get much better synergy between your teams, right? Because if that happens, folks in dev and software engineering will have a much better appreciation for the wisdom of operations, which will actually lead them to build and design better, more reliable services. Right? Back pressure is also what happens when the operational load in these services that are supported by SRE gets too high. That load has to be shared with the people that are actually building the features for that service. At times, the SRE might actually hand the pager back to development. Okay, and that, for example, here again, kind of here at Google, there's actually two circumstances where that might happen. The first one is if the service is too noisy, too toil intensive, very difficult to support, and we're not getting the sort of the investment from our partner development team to fix all of those things, we will hand the pager back and we'll say, if you're not going to fix it, you run it. The exact opposite circumstances can actually lead to the same outcomes. If the service is so successful and so smooth that there's nothing for SRE to do, yeah, we'll hand the pager back and say, hey, like, we did it, you're done. Let us go on and do something else, because the operational load for this service is so low that the development team can handle it without any SRE assistance. So in order to be able to continue to do a good job, in order to make tomorrow better than today and engineer to the SLO, there have to be ways that the team can push back when their workload becomes too much to handle, right? So, like you can, for some examples, right? You can give 5% of the operational work back to developers. You can have them participate in on-call shifts, participate in rollout management, operational tasks. It really helps them, stay sharp in their operational practices, and in some cases, feel some of the pain so that they can get some of that motivation to fix some things that may need to be fixed. It's also really important to track the project work of the SRE team as an engineering team, to actually track what projects they're delivering. And if they're not able to deliver completed projects, then something is wrong, right? You should know that it's actually It's easier to push back on it, on taking on a new system, than to give a system back once it is onboarded, right? So as you evaluate systems to be onboarded to SRE, analyze them carefully and only onboard them if they can, in fact, be operated safely. If every problem in the system has to be escalated to developers, then SREs really aren't adding value. You have to give the pages back to developers and let them be that first point of contact. So a word about leadership buy-in, right? Without leadership buy-in, SRE cannot work. Leadership buy-in is required for every aspect of SRE, for air budget policies, for capping toil, for shared responsibility, right? If your leadership doesn't back up the air budget policy, you're going to have to go all the way back to principle 1 and fix that again. This is incredibly important, right? When your applications miss their SLOs, this actually puts a lot of additional load on the SRE team. They have to spend much more time fighting fires, and they will accrue more tasks to do to improve the system. But because they are under additional load, they don't have time to do those tasks, so the problem just continues to cycle out of control. Your leadership is really best placed to help here, right? They can either fund a focus on reliability, or they can agree to actually loosen the SLO, right? It is okay to loosen, to lower your reliability target, to give the team space to dig themselves out, right? Now, one warning sign might be, hey, if the page is going off too often, can't we just hire more people to answer it? Well, that's not the right thing to do, right? The correct thing to do would be to prevent the pager from firing too often, which means to reduce the rate of change, freeze pushes, to refocus development on fixing things that we've identified in our postmortems, and to overall improve the health of the application itself. Just throwing people at an operations problem like this, sometimes we call it feeding blood to the machines, that's not how we think about solving these kinds of problems, right? We know that fixing issues after release is always more expensive than fixing them in the first place. So what we want to do is aim for reliability and consistency up front. This is a place where SRE teams can actually help and provide value, especially when things are working well. By consulting on designs before the launch, we can apply the lessons that we have learned and fixes that we found and implemented before the launch and not after, right? In this world, in this model where we share responsibilities, being able to consult on design and actually, in some cases, block launch until vital concerns have been dealt with can really reduce the toil of SRE in the long term. Automation is another way by which we regulate workload, and this is a key engineering solution, right? There's really 3 places where SRE teams can benefit from automation, right? We can eliminate toil, to automate the things that need to be done over and over. We need to do a better job. We can do a better job of capacity planning, right? To do things like auto scaling rather than manual forecasting. And maybe even in some cases, we can actually fix issues automatically, right? If the fix to a particular issue could just be written in the playbook, maybe we could just make the computer do it itself, right? Ultimately, automating away toil and operational load is how you get SRE teams to be responsible for more and more services without a corresponding increase in operational overload, right? So this is how we scale the team up non-linearly with the number of services they support. So this is our 3rd principle, right? SRE teams have the ability to regulate their workload. Once the team is up and running, this is the principle you can apply to allow for growth and harmony while scaling up our operations as you grow. You can add more services, you can develop larger systems. Now, let's talk about the 4th area of focus for SRE, or the 4th principle, which is building a culture of blamelessness. Let's start by thinking about anti-patterns that we may have all seen, and we talk about why blame is dangerous. I think the nuclear alert false alarm that triggered panic throughout the United States state of Hawaii back in 2018 is an interesting case study. All right. For those who don't remember what happened, human error caused a statewide emergency alert to go out about an inbound nuclear missile attack. As you can imagine, that is quite scary, right, for everyone involved. I was reading an article about this in Wired, and there's this line that said that the state representative said, I'm really angry and people should lose their jobs if this was a human error, if this was an error. This is actually an anti-pattern to how we in SRE think about these things. We know that humans make mistakes. That's just how it is. It is impossible to prevent humans from making mistakes. And you need to look at the system itself to figure out how it can be, sorry about that. Let me just get back to where I was for a second. So we know that humans are going to make mistakes, right? It is impossible to prevent humans from making mistakes, but we need to engineer the ability for errors to have an impact out of the system itself, okay? So in this case, everyone who was involved should have asked the question, not who made the mistake, but what was it about the system that allowed the operator to send this message, this erroneous and alarming message, right? We know that we're going to be setting our SLOs to 100%. We've already talked about how 100% is an impossible goal. And if you do set such an objective, you're just setting yourself up for failure. And then you're required to treat every outage, no matter how small, as an emergency. This just burns people out. And so how do we embrace failure? Well, we model blamelessness at all levels, right? So for example, there's a story about how someone who kind of just joined SRE was working on a capacity plan in a spreadsheet, and they made a mistake, and the capacity plan was wildly incorrect, right? And of course, I was scared about being blamed for it, and the director basically said, well, the problem is in the process. Why did this mistake not get caught? Why did it make it all the way down into the capacity plan? How can we fix this? How can we make this process more robust? Okay. We want to stamp out blame wherever it is found, right? So another example is this this thing we do at Google called an ops review, where we kind of go through incidents that have happened, and we go through the postmortems, and we talk about lessons learned and things like that. And one of the cultural aspects of that is that we are not allowed to say anything negative about someone unless it's yourself or the other person is in the room. Right? Because again, we're focusing on the system, not the people. Okay. And in some cases, we can actually, we celebrate cases of, hey, I made a mistake that then lead to outages being resolved faster, right? So this is an example from the SRE book, right? There was an SRE who pushed a release, and even though the release was tested thoroughly, and there was something unexpected that happened, and they took down a critical service for about 4 minutes, right? The reason this incident only lasted 4 minutes is because this person had the presence of mind to do an immediate rollback, right? And they averted a much longer and larger scale outage, right? So this person basically got recognized for this, right? So you could say that, well, they should have been, maybe punished or whatever for pushing the release and causing the problem. But the thing that we're really focused on is, what do they do to fix the problem? And they didn't hide the problem. They didn't prevent that. They didn't pretend that it wasn't happening. All right. So that's how we embrace failure at every level, and that's how we kind of build this culture of blamelessness throughout the organization. But failure on its own is obviously not great, right? How can we benefit from failure? Well, once we've embraced it, we need to learn from it. When an outage happens, and it inevitably will, right? We've already paid a price, right? We want to write a postmortem or a retrospective to reap a reward for the price that we've already paid. We want to include prioritized actions that are aimed at eliminating these classes of errors and making the system more robust. And then we want to make these documents widely available so that everyone can read them and learn from them and learn to get better at detection, prevention, and mitigation of these kinds of incidents faster in the future, right? Human errors are systems problems. You can't fix people, but you can fix systems and processes to better support people in making the right choices, right? You want to keep asking why, right? When you're doing your retrospectives, when you're learning from failure, the question is why. You want to think about what are the things about our system that went wrong and what can we do to fix it, okay? So this is all sort of a summary of our fourth animating principle, which is failure as an opportunity to improve, and therefore we should celebrate it, right? It is not an excuse to brandish pitchforks. So here are the some of the takeaways for the fourth principle, right? We know that failure is going to happen. There's no way around it. When it happens, don't point fingers, use it as an opportunity to improve, okay? And you have to do so in a proactive way by taking the lessons you learn from each failure and actually putting them into practice. So to summarize what we've talked about today, SRE, site reliability engineering, can be distilled down into four major principles. We need service level objectives as reliability targets for our system, with consequences that we're signing up for if we do not meet them. We need to have time to make tomorrow better than today through software and systems driven improvements. We need the ability to regulate our workload through automation or pushing back when operational load gets too high. And we need to treat failure as an opportunity to improve, right? We remove the word blame from our vocabulary. We know that things will go wrong. And if blame is assigned, it just incentivizes people to cover up incidents and systems faults that, if we were to address them, would actually make the system more robust and more reliable. You cannot run an effective organization on the basis of fear. So before I answer questions, I wanted to highlight some resources if you want to learn more about SRE. There's the original SRE book that we published with O'Reilly back in 2016. It introduces the principles, practice, and culture. This book that was very well received, but one piece of feedback was, hey, it's great if you're Google, but like this can't possibly work for us. So we published the site reliability workbook, right? They're meant to be used side by side. And so the second one kind of provides some practical examples of how, especially companies outside of Google, like Home Depot, Evernote, Niantic, who runs Pokemon Go, actually put these things into practice. And then there's a third book edited by David Blank-Edelman, which provides an industry survey of how practitioners at other companies have applied SRE and adapted it to their unique circumstances. If you go to google.com/SRE, you can actually find at least the first two books online for free. So I want to thank you very much for your time and attention. Really appreciate it. And at this point, I would love to answer any questions that we may have.